Hello friends, welcome back to your UPSC. So today we'll start with another topic of geomorphology, that is plate tectonics. So let's get started. So in plate tectonics, we will first understand what exactly plates are. Plates are rigid lithospheric slabs or rigid and solid crustal layers and they are called plates. See, this is a lithosphere and this crustal layer, okay, this crustal layer, solid crustal layer is known as plates, okay. And in plate tectonics we actually study the whole motion and resultant deformation of the plates, okay. The whole motion, plate motion and their resultant deformation is studied in plate tectonics, okay. So so we have 6 major plates and 5 minor plates. So 6 major plates are American plate, Pacific plate, African plate, Eurasian plate, Indian plate, and Antarctic plate. Okay, and five minor plates are Caribbean plate, Nazca plate, Scotic plate, Arabian plate, and Philippines plate. Okay. So these were our plates. Now we will talk about plate tectonic theory. Plate tectonic theory, as we have discussed, it is plate tectonic theory studies about plate motions and their resultant deformation, okay? And it is majorly based on two scientific concepts. What are these two scientific concepts? These scientific concepts are continental drift and seafloor spreading, okay? Continental drift we have done. Now we will study seafloor spreading and then plate tectonics, okay? And plates are basically classified into three types, okay. First is oceanic plates, second is continental plates, and third is continental oceanic plate, okay. Now we will study about plate margins. Plate margins and plate boundaries are where two plates meet, okay. So like see, here we have, this is our, this is our Pacific plate, okay, and this is our American plate. This is the area, or this is the boundary where these two plates are meeting, and this boundary is known as plate margin, okay. So we have basically three types of plate margins. First is constructive plate margin, second is destructive plate margin, and third is conservative plate margin, okay. Now constructive plate margin is also known as divergent or acritic plate margin, okay. In this plate margin, what happens is the two plates, see there are two plates, okay, they move apart from each other, okay, and because they are moving apart, this area is open, and in this area we have asthenosphere, okay, which is containing hot lava, okay. This magma rises and it fills inside here. This magma rises in the form of fissure volcano, okay. Now, so this fissure volcano occurs and the new crust is formed. And due to the divergent plate boundaries, we have volcanic activities, creation of new oceanic crust, formation of submarine ridges. Okay, we will talk about it later in seafloor spreading. Submarine ridges are formed, and next is creation of transform faults. Okay, and then next is occurrence of shallow focus. Okay, we have like shallow focus earthquake here because they are moving apart, so earthquake also occurs. And last is Drifting of oceanic plate. Oceanic plates are drifting apart from each other. Now, the next plate is destructive plate margin. First, we will see what are the constructive plate, where we have constructive plate margin. So we can see this whole area here. This is mid-Atlantic ridge, and here we have constructive plate margin. Okay, this area near Africa, moving towards Pacific Ocean. Okay, going through Australia. This is a constructive plate margin, and here we have this area. This is also constructive plate margin, and here you can find ridges all over. Okay, this is the biggest ridge. Okay, we have mid-oceanic ridge here. Now next we will study destructive plate margin. Destructive plate margin is also known as convergent plate margin or consuming plate margin, because here what happens is there are two plates. Okay, this is one plate and this is the second plate. They come towards each other. Okay, so either one of them is subducted or both of them rises to form forward fault. Okay, now there are three types of collision in constructive plate margin. First is ocean-ocean collision. In this collision, the oceanic plates, they collide with each other. Okay, next is ocean continent collision. In ocean continent collision, there is one oceanic plate and the second one is continental plate. Okay, they collide with each other, and the oceanic plate being heavier, it subducts inside. Okay, oceanic plate being heavier, it subducts inside, and the continental plate, it rises up. So this subducting zone, from where this plate is subducting, it is also known as Benioff zone. Okay, and the opposite of subduction is abduction. Abduction. Okay, so in this what happens is there is thrusting up of the plate. Now next is conservative plate margin. Conservative plate margin are also known as transform fault boundaries. Okay, this we have done in faults also. In this what happens is there are two plates and they slide with each other. Okay, they slide past each other, and because of this mild earthquakes occur. Okay, so these are conservative plate boundaries. Sorry. Now, next we will study, as we have done this plate margins, now we will study about seafloor spreading. Now, before studying seafloor spreading, let us look into few examples of collisions. First, we will see about ocean-ocean collision. So, in ocean-ocean collision, we can see here in East Asia, these plates, when they collide with each other, okay, there we can see ocean-ocean collision in East Asia. Next, we will see the example of ocean-continent collision. Ocean-continent collision, we can see the best example is here. We have Nazca plate. This is oceanic plate. And here we have American plate. This is continental plate. They collide with each other. Okay. So, this is our ocean-continent collision. Now, because of this, Andes are formed here and Rockies are formed here. Okay. Lastly, we have continent-continent collision. So in continent-continent collision, we can see here we have African plate. Okay. And this African plate, it collides with Eurasian plate. And because of this, when they are colliding with each other, Himalayas are formed. Okay. So this is the example of continent-continent collision. Okay, so now we will study, as we have done this, now we will study seafloor spreading. So, seafloor spreading, it is a concept propounded by Professor Harry Hess during the time of Second World War. Actually, Harry Hess was a geologist as well as he was a part of American Navy, US Navy during Second World War. So at till that time, what everyone thought was that oceanic floor is flat. Okay, it is flat and it does not have any any landforms like we have on continental surfaces. But to the surprise of Harry Hess, he actually used sonar. So sonar was used in Second World War to locate enemy submarines. Okay, so during free time he used sonar to calculate the depth of the ocean. Okay, so what he found that at some places there the depth of the ocean was very shallow. Okay, and other places it was very deep. Other places it was a normal or plain, or other places it was little bit high. Okay, so this with this he made the conclusion that the oceanic surface is not flat, it is also having some landforms like we have ridges, trenches, guyots, and all that sort of things. Okay, in the oceanic crust, oceanic floor. Okay, so after that what happened was he uh, he even did the in-depth study of this oceanic crust with other scientists. He found that there are bands in this magma-driven conveyor belt. There was a conveyor belt, okay? Here beneath the oceanic crust, there is a conveyor belt, and in this belt, we have bands. So here we have ridges, okay? These we have ridges, and here we have bands, and these bands are located at equal length. Okay, they are located at equal length, and they are moving towards continent. Now how did they found that they are moving towards continent? When they drilled these bands, okay, they found that this one was the youngest. Okay, the one which was near the ridges, they were the youngest rock, and the one which were farthest away from the mm, ocean and nearest to the continent were the oldest rocks. Okay, so these were the youngest, or these were the most new, and these were the oldest rocks. Now, they also found that these bands have polarity. Now, polarity simply means that they about their magnetic north. So, the one here was having different magnetic polarity than this one. Okay, this one was looking having the north towards Arctic, and the another one was having the north toward Antarctic. Okay, so with this they concluded that two, these two bands, they were at some point of time they were single rock. Okay, and now they are moving apart from each other. Now, why they are moving apart from each other? This is cool lithosphere, okay, and beneath here we have asthenosphere, which is having hot molten magma. Asthenosphere, okay, this one is having hot molten magma. So this magma is rising up, and because of the rise of the magma, these I'm so sorry, these plates are moving apart, which is making this magma to rise up. Okay, and here um, this area is filled by this hot molten magma, and this is forming ridges. Okay, this is how continental ridges were formed. Now Harry has thought that because the sea floor is spreading, then the earth should be enlarged in size. Okay, see, this is our earth, this is a part of our earth. Okay, and if the sea floor is spreading constantly, okay, then the earth should be enlarged in its size, but it is constant. Okay, but the earth is not enlarging, it is constant. Now why is it so? So this theory was not ended here. Harry has told that if the see this area is enlarging, then there must be some area which is decreasing. Okay, so this gave the concept of plate tectonics. Here comes the whole concept of plate tectonics. So this is the concept of plate tectonics we will study. Now this hot matter is rising because these two plates, they are moving apart. Okay, they are moving apart from each other, which is leaving a blank space here. Okay, and now this blank space is filled by hot rising magma. Okay, in the form of these fissures are filled. Okay, and this is forming ridges, oceanic ridges or rift. Now here they are moving apart, and the continent, this is the oceanic plate and this is the continental plate. Okay, so this oceanic plate being heavier, what happens is when they come towards each other, this is spreading. Okay, we have done this is spreading and this one is converging. Now as they are moving towards each other, they are converging plate boundaries, and I have told you that the heavier one will subduct. Which one was the heavier one? Oceanic one. So the oceanic plate will subduct. Now because it is subducting, here we have loss of a land. Okay, here we have loss of this much area. Now this is what Harry Hess was saying, that if here we have landform formation, we have new land is formed or new crust is formed, there must be a place where we are losing some of our land. Okay, so here we are losing our land. Now because of this, we have mountain formation in the oceanic seafloor. Now, here, because this is converging, here trenches are formed, oceanic trenches are formed. Okay, and because of their subduction, because of collision of these two plates, we have folded mountains here. Okay, here we have folded mountain, and you see this plate has submerged inside, and inside we have, till here we have cool lithosphere, but below this we have hot asthenosphere, and because of this high temperature this plate will melt, and because of the melting of this plate, what will happen in this area? Magma will become, we will have more magma. Okay, so because we have more magma, the pressure will be exerted, upwards. Okay, towards the weak crust. Now the pressure will be exerted, and the magma rises from the cracks, and when it rises it forms volcano. So these are active volcanoes and they are explosive too. Okay, so they form volcanoes. So here we can see volcanoes. Now this was the whole concept of plate tectonics. Now we will study how plate tectonic the relation of plate tectonics with earthquake. Now what happens is when these two this plate is moving apart, okay, this oceanic plate, this area is cracked, and because this area is cracked, we have mild earthquake here at the boundary, okay, and we have mild earthquake at this lithospheric area too, because here the plate is subducting, okay, so because of subduction there is a movement, and because of this movement we will have mild earthquake here, but the plate which is being subducted inside, this will experience high earthquake, okay. So this will experience high or deep earthquake. So now we can easily say that the constructive plate margins will experience mild earthquake, and the destructive plate margins will experience deep earthquake, okay, high earthquake. And now this was earthquake. Now we will study about volcano. The constructive plate margin here, when the plates are moving apart, here we can see fissure volcanoes, which are very slow volcanoes, okay. They don't form any sort of cones or anything. There is just the when the sorry when the plates they move apart, the area is left blank. So this area is left blank, and here magma rises and it's spread all over, okay. So this is oceanic ridge, or we can say fissure volcano. Now, as I've told you, this plate which is subducted, it will lead to rise of magma because of melting of this plate, and this will form active volcanoes here, okay. Here we will have volcanic mountains. Next is plate tectonics and formation of mountains, folded mountains. Now how folded mountains are formed? See, when these two plates they collide with each other, there are fold there are fold in the plate, okay. So these folds lead to the formation of mountain, okay. So this is how mountains are formed, folded mountains are formed, okay. Next we will have the relation of plate tectonics and tsunami. So now what happens in tsunami? Tsunami occurs when uh, due to three reasons. First is when there is volcanic eruption. Okay, so there can be volcanic eruption here. So when there is volcanic eruption, the tsunami is caused because due to the tremor or whatever impact, this waves are formed, and the huge waves are formed which are known as tsunami. And due to earthquake also, this tsunami is caused, and due to subduction of the rock, subduction of the crust or this plate, a tremor is caused, okay. Here tremor is caused. Because of this tremor, huge waves are formed, and these huge waves are known as tsunami. So this was all about plate tectonics and its relation with various things like earthquake, mountain formation, etc. So that was all. So guys, that was all for today's lecture. I hope you enjoyed the class. So let's meet in our next class. Till then, take care and have a nice day.